This video is going to demonstrate the inversion of a matrix by a paper and pencil method. The method being used is known as the Gauss-Jordan method, and it's described on page 44 of the book Linear Algebra and Its Applications by Gilbert Strang. The method used for inverting the matrix is a modification and perhaps a somewhat more complex version of successive elimination. To demonstrate the inversion of a matrix, we're going to invert the 3 by 3 x prime x matrix from the hospital data. The x prime x matrix is the matrix generated by hospital size, visibility of consequences, and the intercept term. That matrix is shown here. The first step in the Gauss-Jordan method is to put an identity matrix, that is a matrix with ones on the main diagonals and zeros in all other cells, beside the original matrix to be inverted. Now the process that we are going to follow will be to first, using the method of modifying a row and subtracting it from another row, we're going to zero out these three cells. Then we're going to go the next step of zeroing out these three cells. When we have completed that process, we will then make these three cells equal to 1. When that is done, the inverse will appear here. So the first step in the process will be to say that this new row is equal to the original row. And now we're going to use that row to zero out these two places. And in order to do that, we're going to begin with this value being equal to the original value minus that value again. And we're going to change that so that it is $A3 divided by this value, and we're going to actually make that $A2, and then times that value again, and we're going to change that to $A2. The dollar signs allow us to copy this formula to other cells and have it remain correct. Now when I say enter, I have basically zeroed out this first cell, and the way I've done that is I've taken this value and I've subtracted the ratio of these two values times this value. I've taken this value and I've subtracted the ratio of these two values multiplied times the first value. And I'm going to do essentially the same thing in every cell with some minor differences. Now I'm going to drag this all the way across, and if we look at this one, what I've done here is I've taken this value and I've subtracted the ratio of these two times this one. And that's the same thing that happens all the way along. This value, subtract the ratio of these two times this one. Now because I have fixed the formula with dollar signs, I can drag this on down, and again I get a 0 here. And the reason is that I have simply moved the blue box down one cell. Now I'm going to copy this across, and if we look at this one, for example, I've done essentially exactly the same thing as I did here, except I've moved it down one cell. Okay, that's the first step. We've zeroed out these two cells. Now let's take the next step, which will be to zero out this cell. In order to zero out that cell, we're going to say that this is equal, and we're going to basically just copy the first two rows this time. Now, this value, which is going to be a 0 coming from here, is going to be equal to this original number minus the number again, and again I'll fix that as $8, divided by this value, and that will be fixed with the $7 times this value again, and that requires no fixing because I'm not going to copy it down another row. So I now have a 0 here. When I drag it this way, I still have a 0, and when I drag it here, I now have these additional values. So we've gone through what is known as the forward part of the Gaussian elimination. We're going to now go to what's called the backward part, and the way we're going to do that is we're going to take this row and we're going to use it to zero out this cell, and this cell. So the first step will be to move down here to this point right here and say that this is equal to, and copy this all the way along. Now at this point, we want to get rid of these two numbers. We want to turn them into zeros. To do that, we will use the same process as before, but in reverse. This is now equal to this value here minus the value again, and I'll fix it so that we always stay in C, divided by this value, which will always be the divisor, so I'll fix it with a $C$12, times this value again, but that value will be moving down one row when we move to the next row, so I will fix that in this way. And now I've zeroed out that cell, and I'll drag this here, and I'll drag it here, and now I'll drag it down, and I've zeroed out that cell, and I'll drag these across, and I'll drag these across, and now we've zeroed out these two cells. In the next iteration, we will say that this cell is equal to this cell, drag that down, and then drag it all the way across. Now what we're going to do is we're going to zero out this cell using this cell. So for this value, we will say that it is equal to this cell minus this cell again, and we'll fix that with the $B divided by this cell, F4, times this cell again. When I hit enter, I've zeroed that cell. Now if I drag this across, I still have the 0 here. I drag it to the left, and I still have the same number here. We have now essentially zeroed out these top rows, or these top cells, and these bottom cells. And the only step remaining to get the inverse here is to divide each one of these rows by this main diagonal value. So we'll move the sheet down a little bit, and here we'll say that this is equal to this value divided by this value, and we'll fix that with an F4 and copy that all the way across. And then we'll say that this value is equal to this value divided by the same number again, F4 again. Now we've got a 1 here. Drag that all the way across, and also in this direction. And then the value that will go in this cell is equal to this value divided by itself again. Again, fix it with an F4 and drag it all the way across. And for symmetry, we'll drag that. Now, this is the inverse of this matrix. To show that, I'm going to calculate the result of multiplying x prime x times its inverse, and I'll do that here. So this will be equal m mult. I'll go up and get the original matrix, then put in a comma, and I'll go back down so we can see the result, and select the inverse matrix. Control Shift Enter. Now this doesn't necessarily look like it's ones on the main diagonal and zeros otherwise everywhere else, but if I reformat the cells as numbers, and I say I want no decimal places, I get 1, 0, 0, 0, 1, 0, and 0, 0, 1. And in fact, the definition of the inverse is that when we do this multiplication, the original matrix times its inverse, we get this identity matrix or this unity matrix, the matrix with ones on the main diagonal and zeros everywhere else.